Bismillahirrahmanirrahim. Dear students, in our today lecture, we are going to discuss about the power management solution in wireless sensor networks. Dear students, as you will know about the environment of the WSN, that is the wireless sensor networks, in which sensor nodes deployed in some toxic environment, and the only source of energy is the battery. But with the passage of time, the battery goes down and the sensor network nodes stop functioning. Therefore, the overall efficiency of the sensor networks goes down. So this is the main issues regarding the wireless sensor network power management. So, and this is a very hot topic nowadays in research. Therefore, we are going to discuss it in detail in our today lecture. As you well know that my name is Muhammad Suhail, lecturer in computer science. The further slides will regarding this main topic, that is the power management solution in wireless sensor network. Okay, in our today lecture, I want to summarize the main outline regarding our today topic. That is the first of all, we will talk about the introduction to the WSN. It's not necessary that you people already well know about this in our previous lectures, but I want to recapitulate it once again, and gradually I will go towards the problem statement, that is the regarding power management. We will corner the problem inside the WSN environment, okay, and then we will discuss some energy management in the WSN, that what is the energy management and why energy management is required in WSN, and along with the energy management efficiency in wireless sensor networks. And then we will discuss a very detailed solution in a form of a case study regarding this topic, and we will have to explain in detail the main methodology of the finding a solution of the power management. That's especially regarding our main topic, that is the clustering technique. We will discuss it in further point, okay. And then some sort of references. As I told you that references are very important, so at the end you people may have to put question and questions, and I will answer you in my inbox. You can find it. That is the solution regarding your questions, okay. And then the last slide will be regarding some sort of assignment, okay. So let's start. This is the main definition of the wireless sensor networks. That is the collection of large number of sensor nodes. Such nodes are monitors the environment system by measuring the physical parameters like pressure, temperature, humidity, etc. As you can see to the diagram, that the sensor nodes are deployed in some environment, and the number of sensor node may be from 100 to thousands, depend upon the situation and depend upon the problem under observation. All these sensor nodes sense the physical parameters and record the data and transmit the data to the sync node, and after that sync node transmit the data towards the base stations, and then on that data people do some sort of analysis and work. So this is the main definition of the wireless sensor network. Dear students, you will know about the application of wireless sensor networks in detail. That's as you people know that it is a very hot topic nowadays. Sensor network, very hot, and people are going towards the sensor network environment. You can see to the military related application, whether we are seeing to the smart transportation, smart world, entertainment, medical health sciences, security, industrial control, environmental monitoring, etc. Its applications are very huge. Okay, dear student, now we are going towards the sensor node issues, which is very important point, that what are the issues in the sensor node. We are talking about the sensor node, which are the part of the unit part of these wireless sensor networks. As you people know about this, that the sensor node is limited in power supply, limited in computation, limited memory, slow communication speed, and it may not have some global identification such as an IP number, etc., etc. And also, a main problem is these sensor nodes are prone to failure because of its deployment, which is normally occur in some sort of toxic environment, and energy constraints because of the limited power source, that is the battery. So, and also these sensor nodes need to be densely deployed. As I already told you people that the number of sensor nodes deployed in the environment depend upon the problem under observations. That is, its number may be from 100 to 1000, etc. So this is another problem, that these sensor nodes are very in large number. Similarly, these sensor node may have some sort of calibration issues, localization issues, data communication accumulation, and data broadcasting issues. So all these problems may occur in the wireless sensor network environment. Dear students, nodes are battery powered. You will know it. Okay, nodes of the sensor network environment are battery powered. And one thing more, that nobody is going to change the batteries. Why? Because of the dense environment, dense, also the inaccessible, and also its continuous operations. That is, the sensor node operate continuously, and with the passage of time the batteries goes down. So it means that the lifetime of the sensor node is very, very important. Okay, dear students, so you will know about the lifetime of the only source of energy of the node, that is the battery. It means that the WSN power management needs some attention. So we can also manage the power by collecting some extra power, that is from the environment. One can get the energy by harvesting the energy, and the harvesting energy have many methods. You can see the diagram, that is the solar by the radio frequency management, and the vibration, and the thermoodically we can harvest the energy from the environment, and this way we can improve the power of the wireless sensor network. Similarly, in this way we can store extra power, that is the batteries. But the main important thing is that harvesting the energy in the wireless sensor network environment is not easy, because it have its own issues, connected with the topological structure of the environment of the wireless sensor network environment and other more. But the main important point is that one can use the only source of energy efficiently. That is, if someone operate the wireless sensor node intelligently, in this way the source of energy can be preserved. So this is our main issue, and then we will corner it in our coming slides. That is the by efficient usage of the energy, one can improve the power of the wireless sensor nodes, and in this way extending the lifetime and reducing the maintenance of the wireless sensor network environment nodes. Now, dear students, we are going towards our main problem regarding with the sensor nodes, and I am explaining the problem in steps. In first step, we are concentrating that the sensor nodes with a limited battery power supply involved in many activities such as sensing, data gathering, processing and communication. It means that it needs and all these things and all these activity sensor node do it continuously. And in second problem is that the replacement of battery, this is not possible. Look at to the picture on the slide. Thousands of the sensor nodes are deployed over some sort of large geographical area. So even identifying the sensor node that where it will be deployed is not possible in wireless sensor network environment. Okay, so dear students, you will know about the problem regarding the wireless sensor network node, that is the battery, the only source of energy, whereas the topological problem in deployment, that is the access to the battery or replacing is not possible. So it means that there is need some sort of mechanism to improve the lifetime of the sensor node, some intelligent mechanism. Okay, dear students, we are talking about the energy efficiency management in the wireless sensor networks. Energy, if used efficiently, can improve the lifetime of the wireless sensor network environments. So there are many techniques. One can use it the workload management in WSN, similarly intelligent data gathering in WSN, also optimal deployment of the nodes in WSN. But in our topic we are concentrating on the clustering in the wireless sensor network environment. It's very interesting one. So dear student, we selected the clustering technique for the wireless sensor network environment. Clustering is the hierarchical structure of the wireless sensor network environment, in which one node is considered as the leader node, which is called the cluster head, while other are considered the cluster member of the cluster head. The cluster member nodes are responsible for sensing the physical data and transmitting their respective data to the respective cluster head, and the respective cluster heads further transmit the data towards the base station. So in this fashion, you can see the diagram, the data comes around the base station. Okay, Dear students, we are going to explain the case study regarding the selection of the cluster head, which we have already selected the clustering technique for the managing the power of the sensor node of the sensor network environment. Dear student, we will identify some required parameters and their characteristics from start of the sensor network environment operations. Okay, that is the targeting the parameters which are responsible for calculating the cost value of the sensor node at start of the sensor nodes deployed. Okay, and after that rational adoption of the parameters for the cluster head selection. By rational adoption, we mean that which parameter is selected for the selection of the cluster head environment and when it will be selected. This is the point. Similarly, cost values calculations. Okay, and the cluster head will be selected using game theoretic way. That's okay. We are using game theory for the selection. And here I am explaining you that we are explaining the case study by applying two types of game theory, that is the evaluationary genetic model and the Stuckelberg leader and follower game model. Normally we are using the evaluationary game theoretic model for the evaluating the cost value of the cluster head rational selection, and for the Stuckelberg leader and follower game we will use it for the routing the economical path of the cluster head towards the base station. Okay, dear students, as I already told you that in our this method we are using the two types of game for evaluating the cost of the selection of the cluster head in the wireless sensor network environment. Look into the scenario of the game 1, that is the sensor node deployed in the sensor field. Consider nodes division in clusters. Okay, cost model for cluster head selection. This is the very important model. In coming slides we will explain it in detail. Similarly, energy cost for sensor node being a cluster head and energy cost for node being a cluster member. That's for both. You have to calculate the energy cost for cluster head and cluster member both, and then utility function is found, which is very important, and then evaluationary game theoretic approach. By using this one we can easily evaluate the required parameters, the required node for acting as the cluster head at the start of the deployment of the sensor nodes. Okay, parameters at the game 1, that is the at start of the game, at start of the sensor network environment, are considered the degree of connectivity and the received signal strength. These two parameters, since it's very countable and very important for the rational selection of the cluster head environment. Okay. Okay, dear students, look into the slide in detail of the proposed game 1 mathematical model. This is the cost model for a node being a cluster head for degree of connectivity. Especially 4 main steps has to be considered while calculating the energy cost. That is the energy spent to transmit packets to the base station, energy spent to transmit packets to the cluster member, similarly energy consumed for aggregating the packets received from cluster member, and the energy consumed for receiving packets from base station. That is the equation number 1. Similarly, equation number 2, that's the electronic energy, depends on the factors such as digital coding, modulation, filtering, and signal spreading. This is the energy cost in the circuitry per bit for either transmission or reception. Okay. Dear students, for aggregating cost, you can look into the equation number 4 and further equation number 5, and if we put all these equations in equation 1, we can have the cost of cluster head in all aspects in a form of equation number 6. That is the cost of the node having high degree of connectivity selected as cluster head. That is if from equation number 6 this will be applied in start from on all the nodes of the clusters, and the node with the high degree of connectivity value will be selected the cluster head for this time period. Okay. Yes, dear students, we cannot ignore the cost model for being a cluster member for degree of connectivity, which is in the form of equation number 7. Okay, so in this way we can calculate the costs of the cost value for the cluster head and cluster members. Dear students, same methodology is used for another parameter which is called received signal strength. That is the same procedure you can use it for received signal strength and calculate the cost value for game 1. Dear students, game 2 is not a separate game, but here you can consider a very most important parameter along with the previous parameters. You can add these parameters by calculating the cost value of the sensor nodes in selecting the cluster head and the cluster members. Why? Because with the passage of time, the energy of the cluster head depletes very fast as compared to the cluster member, because cluster head do transmitting as well as receiving. That is, the aggregating energy cost is very high of the cluster head as compared to the cluster member. So residual energy of the cluster head deplete very fast as the passage of as the time goes on. Okay, so another parameters, that is the packet drop ratio and the cluster head connectivity with other cluster heads. These are very important parameters which has to be considered with the passage of time. So here I am going to separate the game 1 with game 2 by putting additional parameters like residual energy, packet drop ratio, cluster head connectivity with other cluster head also along with the previous parameters are considered for the selection of the cluster head. Okay, so these are very important. Okay, dear students, the third game in the proposed method can be the selection of the energy efficient route for the cluster head among all cluster heads of the sensor nodes. Why? Because after game 1 output and game 2 output, we have economical and efficient cluster head already. Okay, and these economical and efficient cluster head will now communicate and find out the economical route for transmission of data and information towards the base station. I mean that there is no need of transmitting the data from all the cluster head at a time, rather than this method, that is by using the Steckelberg leader and follower game model. We can stop all the cluster head from transmitting by diffusing their energy, but the most suitable one and the required one and the rational one cluster head will communicate only. In this way we can find out intelligent route, and we can impart our contribution towards the power management of the sensor nodes, and can improve the lifetime of the wireless sensor network. Okay, so parameters used in game 1, we have the degree of connectivity, received signal strength, and parameters used in game 2 were residual energy, packet drop ratio, cluster head connectivity with other cluster head. Dear student, you can also add some more parameters by making our method more intelligent one. So there is no need to worry about that, why I am using all these 3 only parameters and here only 2 parameters. You can find out other parameters countable by making our method more intelligent one. Okay. Dear student, this is the pictorial representation of our nodes and our method. This slide is only for your understanding, well understanding that look at to the nodes deployed in the environment. Normal fashion of the sensor nodes are communicate with each and every node of the sensor network environment, but we will only confining, and by using our intelligent method we can only find out the most suitable way and economical way in cost towards the destination, that is the destination node, that is the base station. Okay. Dear students, look into the diagram. This is the main result of our work, that is after applying the third game, that is the leader or follower game, in which by calculating the values of the utility function for each and every node, and selecting the required node with the help of beta value, one can find out the most suitable route in the network environment of the sensor nodes. Okay, nodes that are not currently needed for ensuring connectivity can go to sleep and save energy in this way, improving the lifetime of the sensor network environment. Okay, dear students, if someone asks you about our this case study, that what are the gap analysis of our work, you can answer them by consideration of parameters in rational manners. That is the one point of agenda that you looked into the discussion in the previous slides. That is the from game 1 2 parameters are used, and for game 2 4 parameters are used, and you can also use more parameters even, as I told you earlier. Okay, similarly the second point is the clustering technique, which is the most important one, and even we apply 2 games or the clustering techniques for finding the rational parameters. Okay. Similarly, for performance matrices, we use the beta value for the best result among all possibilities, along with if you want to talk about throughput, packet delivery ratio, average energy ratio, end-to-end delay of data packet, etc. Also, you can see to them that game-based approach in WSN for cluster head selection is used, which in recent research, a very short number of people use this approach. Similarly, no one in research, only short number of people use the couple of games as a one method, that is the applying evaluationary game approach and start of the deployment of the sensor nodes, and after that by using another method of the game theory for the selection of economical route. So this example is a unique one example. Okay, students, you can find it in the recent research also. Dear students, look into the slides that these are the some research gap in literature. You can see that the limitation and summary of the years of different articles in these slides. That some of the people use 2 parameters, some 3 parameters, and some use one method, one approach only. Okay. Okay, students, how was the topic? A little bit interesting and little bit challenging one, huh? Yes, the topic is regarding latest research in the wireless sensor network. You can think over it, you can read to the topic again and again, and if you people have question, put it down and email to me before 20th June of this month. Okay, I will check it and will reply to you people very soon.